Yes. Configuring our own. Yeah. Good evening, all. So before I start, can anyone please confirm whether my voice is clear or not? Yes.
Yeah, yes, it is clear.
Yes. In the last class, I was just discussing about how exactly the data storage and processing is happening within Hadoop, right? Yes. Yes. In Hadoop, data is stored in the form of files, f1.txt. 192 MB. f1.txt, assume it's 192 MB. This 192 MB is divided into smaller parts. Default block size, assume it is 64 MB. Into how many blocks it is divided? Number of blocks. File size by default block size. Three blocks. B1, B2, and B3. B1 64 MB, B2 64 MB, B3 64 MB. Okay. Think that here you got like 30 lakh records. 10 lakh records in this, 10 lakh records in this, 10 lakh records in this. Now, how these blocks are distributed? How these blocks are distributed, right? Yes. How these blocks are distributed? Master and slave. S1, S2, S3. This is master node or name node. Master node or name node stores metadata information. Stores metadata. Metadata means data about data. F1.txt divided into 3 blocks. B1 block, B2 block, B3 block. B1 block stored here, B2 here, B1 stored in S1, B2 stored in S2, B3 stored in S3. Which blocks are stored in which cell? That information will be available within this master node, that is name node. Data processing, right? Yes. Job to process F1.txt. Job always define, okay. Job divided into tasks. Into how many tasks? Number of tasks equal to number of unique blocks. Number of tasks equal to number of unique blocks. How many unique blocks? 3 blocks. Means 3 tasks. T1, T2 and T3. Just observe T1, T2 and T3. Yes. Job to process F1.txt. Yes. Into how many blocks? Into how many tasks? T1 task, T2 task, T3 task. T1 for executing B1, T2 is for executing the B2, T3 is for executing B3. B1 10 lakh records, T2 is for executing B2 10 lakh records, T3 is for executing B3 10 lakh records. Okay. Who should execute this T1 task? Who has to execute this T1 task? T1, B1, T1 is for executing B1, B1 is present in S1, S1 only should execute it. Who should execute T2 task? S2 only. Who should execute this T3? Slave 3 only. Yes. So here 3 tasks are executed by the 3 slaves parallelly. Three tasks are executed by 3 slaves parallelly. So T1 task by S1, T2 by S2, T3 by S3. So when 3 tasks or multiple tasks are executed by multiple slaves, if these 3 tasks executed by these 3 slaves, suddenly if any one slave goes down, suddenly if any one slave goes down, As there are 10 lakh records in this, 10 lakh records in this, 10 lakh records in this one. Two things you can observe. When the slave is down, this T2 task will be failed. 10 lakh records are lost. 10 lakh records are lost means huge loss, right? If it is sensitive data like banking data, T2 task is full. How Hadoop is able to overcome this thing is replication and fault tolerance. What is that? Replication and fault tolerance. Replication and fault tolerance. Replication means duplication. Replication is nothing but duplication.
How many replication copies does Hadoop maintains? Can you configure it?
Yes, yes. Replication is duplication. Default number of replications. Default number of replications. Default number of replications, replicas. Default number of replications, replicas. Sorry. Default 3. But we can increase or decrease, but we can configure. But we can configure. We can configure means increase or decrease. Increase or decrease the replications. Means we can increase to 4, 5, 6, or we can decrease, right? Yes. I'll say how to increase or decrease the replication, but before that, the replications or duplications are applied on a file or on blocks. Are they applied on file or blocks? Just check this. F1.txt. The size is 192 MB. Number of blocks. Into how many blocks it is divided? 192 by 64. 192 by 64. 3 blocks. B1, B2, and B3. B1, B2 block and B3 block. B1 replicated or duplicated by 3 times. B2 duplicated or replicated by 3 times. B3 also replicated or duplicated by 3 times. Totally 9 blocks. Totally 9 blocks. How these 9 blocks are going to be distributed, right? Yes. How these 9 blocks are going to be stored. S1, S2, S3. 9 blocks. B1 here, B2 here, and B3 here. And again, B1, B3, B2, B3, B1, B2. Okay, this is what a name node. Name node stores metadata. F1.txt. B1, B2, and B3. B1 stored in S1, S2, S3. B2 also in S1, S2, and S3. B3 also in S1, S2, and S3. Okay, B1 stored in S1, S2, B2 in S1, S2, S3, B3 in S1, S2, and S3. Job to process F1.txt divided into tasks, number of tasks. Into how many tasks it is divided, nothing with number of unique blocks. Number of tasks in Hadoop always depends on number of unique blocks. How many? 3. T1, T2, and T3. T1, T2, and T3. Job to process F1.txt divided into 3 tasks. T1, T2, and T3. T1 is for executing B1, T2 for executing B2, T3 for executing B3. Who should execute this T1 task? This T1 task is for executing B1. B1 present in S1, B1 present in S2, B1 present in S3. B1 present in S1, S2, and S3. So here T1 task can be executed by S1. It can be executed by S2. It can be executed by S3. So S1 can execute, S2 can execute, S3 also can execute. T2 task also can be executed by S1. T3 also can be executed by S1, S2, and S3. Okay. Assume that to execute a T1 task, the master node has selected S1 only. For executing the T2 task, master node has selected S2 only. For executing the T3 task, master node has selected that. So T1 task by S1, T2 by S2, there is any data loss? Do you think is there data loss? So
So when
here,
the slave goes down, does it replicate again into a different slave node?
so if that particular slave S2 is down, previously in S2, B2 block only was storing in the previous exam. But here, B2 block is stored in S1 and S3 also, right? Even if S2 is down, still data available in S1 and S3 also. Do you think is there any data loss here? The particular slave is down, the particular slave data you can also see in S1 or S3. The previous example, S2 was storing B2, S1, B1, S3, B3. If particular slave down, then B2 data lost. But here, B2 or B1 or B3, the data is available, right?
Yes.
Yes, sir.
Still the data available in S1 or S3. So there is no data loss. So there is no data loss, right? Yes. That is one. Second thing is T2 task. The T2 task, right, can be assigned to S1 or S3. The T2 task can be assigned to either S1 or S3. Yes. Okay. So there is no data loss. There is no task failure. But here I have got two queries. This T2 task will be assigned to whom? Okay, if this particular slave is down, then the T2 task will be assigned to whom? To S1 or S3. What is the criteria followed in assigning the task to a slave? That is one. And here one more query is, T1 task can be executed by S1, S2, and S3. Why it has chosen only S1? T1 task can be executed by S1, S2, and S3. Why it is assigned to S1 only? Why not to S2 or S3? What is the criteria followed here in assigning the task to a particular slave? T2 task also can be executed by S1, S2, and S3. Why only to S2? Yes. So what is the criteria followed in assigning the task to? So there is 4 steps criteria followed, right? 4 steps criteria. Yes, absolutely. 4 steps criteria in allocating. Four steps criteria in allocating a task to the slave. Four steps. Okay, 4 steps. First one. So S1 executing T1 task, S2 executing the T2 task, S3 executing T3 task. This particular S2 is down. Then T2 task. Then D2 assigned to S1 or S3. Okay, then T2 task assigned to S1 or S3. So here 4 steps criteria in allocating a task to the slave. 4 steps criteria in allocating the task to the slave. First one, to whom it should be assigned S1 or S3 means first one, master node selector. Master node selects the slave. It selects the slave. Selects the slave with which is highly configured, which is highly configured means which has got a high configuration, high system configuration. If both are highly configured, if both are highly and equally configured, then master node selects the slave which is more ideal, means more free. Master node selects the slave which is more ideal, more free. If both the slaves are free, if both the slaves are free, if both the slaves are free, then master node selects the slave which is nearest to it. Which is nearest to it means master can be in one country, slave can be in another country. Master can be in one state, slaves can be in another state, right? Yes. So all they can be in the same land, in the same place. Master node can select the slave which is nearest to it. If both the slaves are equally near, if both the slaves are equally near, right? Then master node selects
Sir, anyone is there in this?
what is it?
So this is demonstration over. I wanted to know about this data analytics, sir.
Or yesterday, did you attend the session?
No, sir. But actually today they told to attend me. So I exactly don't know what are the important topics and what like programming languages, what and all I need to learn, and what are the
Yes.
fundamentals I should learn.
Okay. So okay, here master node selects the slave which is nearest to it. If both the slaves are equally near, then master node selects the slave which has good health status, which has good health status. See, even though they have got equal highly configured, but we cannot say they have got good health status or not. Means now and then because of some software or hardware issue, right? So think that if both the slaves, assume that if both the slaves if both the slaves are equally, if both the slaves have good health status, good health status, if both the slaves have good health status, then master node selects any one slave randomly. Master node selects any one slave randomly. Yes. So finally it selects any one slave randomly, but in the first or second time only it can go with that, which is highly configured, which is more ideal, right? So this is the criteria, 4 steps criteria followed in assigning a task to the slave, right? Yes. Yes. So how do see this? Here we follow like master and slave architecture. Single master and multiple slaves. Single master and multiple slaves, right? S1, S2, S3. Yes. Here B1, B2, and B3. So here data is divided into 3 blocks, B1, B2. F1.txt is divided into 3 blocks, B1, B2, and B3. B1 stored in one system, B2 in another, B3 is one. Means single file data is distributed across multiple systems. Means it is divided into multiple parts. Into how many parts? 3 parts. Each part we call it as one block. Each part we call it as one block. Okay, fine. So T1 task is assigned to execute this P1 block. T2 task assigned to execute this B2 data. T3 task to assign to execute this B3 data. T1 for executing this B1, T2 for executing B2, T3 for executing B3. Okay. If this particular slave is down, then the T2 task should be assigned to S1 or S3. So this process we call it as fault tolerance mechanism. What is fault tolerance mechanism? Yes. Fault tolerance. If multiple tasks, assume that T1, T2, and T3. If multiple tasks T1, T2, and T3, if multiple tasks T1, T2, T3 are executed, if multiple tasks T1, T2, T3 are executed parallelly by 3 slaves. T1, T2, T3 are executed parallelly by three slaves, S1, S2, and S3. If any one slave assume S2 is down, if any one slave S2 is down, then the task of that slave and then the task of that slave is assigned to the other slaves, other available slaves. This process is called, yes, this process is called as fault tolerance. It's called as fault tolerance. This process is called as fault tolerance. Okay. Next, I said we can also increase the replication, right? Default number of replications are 3. We can also increase or decrease the replication or blanks. So before I go with that, design principles with respect to replications. Design principles with respect to replication. Design principles with respect to replications. Yes. Replication is applicable. Replication is applicable for only data. Replication is applicable for only data, but not for metadata. But not for metadata, right? Replication is applicable for only data, but not for metadata. Replication is only for data node. Replication is applicable only for data node, but not for master node. And next. So here, all the same replicas, all the same replicas. All the same replicas cannot be within the same slave. All the same replicas cannot be within the same slave. What is this indicate? Same replicas cannot be within the same slave means
Same data will not be in the same slave.
means, for example, this is the master, these are the slaves. Okay. S1, S2, and S3. S1, S2, and S3. So here B1, B2, okay, B1, 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 B2, 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 B3, B3, B3. It cannot be like this. See all the 9 blocks, okay, replicated, B1 replicated by 3 times. B1 replicated by 3 times, B2 replicated by 3 times, B3 also replicated by 3 times. Okay. But suddenly if this S1 is down, B1 data is lost, right? Because all the B1s are stored in S1 only. If B1, B2, B3 in S1, if B1, B2, B3, B1, B2, B3, then okay. All the B1s are stored within this S1. If S1 done, B1 blocks are lost. So all the same replicas cannot be within the same slave. How many maximum replications you can have? Maximum number of replications. Maximum number of replications equal to number of slave nodes. Maximum number of replications equal to number of slave nodes. Okay. So this is what design principles with respect to replications. Okay. Next, we can also configure, increase or decrease the replications, right? So how to configure the block size? By default, 64 MB or 128 MB. We can also keep our own block size, right? We can also keep our own block size, 50 MB. So in the same way, configuring block size and replications. Configuring block size and replication. So configuration and replicate block size and replication means go to Hadoop install folder only, Hadoop etc conf, open this XML. Okay, property value, just one more property and value, right? Yes. Yes, property name slash name value slash value. So default block size, I'm keeping it as 50 MB. One more property. I'll copy this for one more property. This is dfs.block size 50 MB. Next, for one more to set replications. For dfs.replication distributed file system. dfs.replication, right? Yes. How many replications you want? By default, it is 3. If you want to like 4 or 5 or 6, depending upon that. Yes. dfs.replicate. If the data is too sensitive, right? If the data is too sensitive, then you can go with more number of replications. If data is too sensitive, then you can go with more replications. Like sensitive data, like banking data, right? You can go with more number of replications. But if data is insensitive, right? Not that much of sensitive like Facebook, that social media data, Facebook data, right? So you can keep less number of replications depending upon the sense. If the data is too important, you keep more replication. Otherwise, go with less one. Hadoop follows Hadoop follows master slave architecture, right? Single master and multiple slaves. Single master and multiple slaves. Do you think all the systems should have the same hardware configuration? Question, right? Do all the slaves, do all the slaves need to have the same hardware configuration?
No.
No. No. Last year you got some slave. This year you have increased the number of slaves. You can go with any configuration, right? No. You can have any configuration. No. Do all the slaves need to have same default block size? Same default block size? Yes. Need to have the same default block size, yes. Which is advantageous. Having block size as bigger or smaller. Which is advantageous, having block size as bigger or smaller. Hmm.
Smaller.
Hmm.
Bigger.
Hmm. Okay, for example, f1.txt size equal to 1100 1 GB. File size is 1 GB. Assume default block size. Assume default block size equal to 500 MB. Number of blocks. Default block size 600 MB you take. Number of blocks. How many blocks? 2 blocks. 2 blocks. Means two system runs because two systems runs in parallel. Number of blocks, 2 blocks. Means two systems runs in parallel. Number of blocks means 2 blocks, means two systems runs in parallel. Means only two blocks means two systems runs in parallel. Means only two systems are running parallelly. Means only two systems are running parallelly. We get less speed. Means only two systems are running in parallel. We get less speed. If 64 MB means nearly 10 systems will be running. If block size equal to 64 MB, then nearly 10 systems run in parallel. We achieve more speed. We achieve more speed. Next step. f2.txt. We have got f2.txt. f2.txt, for example, size equal to 70 MB. The file size is 70 MB. Size equal to 70 MB. Assume default block size as 10 MB. Assume default block size. If block size is smaller, if block size is smaller, assume default block size equal to 10 MB. Assume default block size equal to 10 MB. Stored in 10 systems. Sorry. Stored in 7 systems. Stored in 7 systems. So here is it advantageous means already the file size is too small. And again, splitting into smaller parts. File size is too small and again splitting into smaller parts. The file size is too small and again splitting into smaller parts. And processing. And later combining it. And later combining it. When we want to retrieve. Again splitting into smaller parts and processing. And later combining it when we want to retrieve. It's a time taking process. Already it is a small file, again splitting and storing in different machines, again processing, again later combining to retrieve the data. So it's a time taking process, right? It is also drawback. So the default block size, it cannot be too big or too small. The default block size, it cannot be too big or too small. So the default block size given is 128 MB for the new versions. Okay, fine. Understood what is meant by fault tolerance, replications, and how this increase or decrease the block size and replications. Increase or decrease the block size or replications, and what is the criteria followed in allocating the task to the slaves. Replication fault tolerance. I'm writing a note here. Whenever we configure the block size and replication, so whenever we configure the block size and replication, we configure means increase or decrease. Whenever we configure increase or decrease the block size and replication, we need to restart the cluster. We need to restart the cluster. Then only, yes. We need to restart the cluster. Then only the changes and modifications will be. Then only we modifications will be reflected. It will be reflected because it reads the conf file. When we need to restart the cluster because it reads the configuration file. It reads the configuration file only once. That is at the start of the cluster. At the start of the cluster. So once the cluster is running, if you keep on modifying, it won't reflect. Only if you restart the cluster only, the changes, modifications will be reflected. Otherwise, it will take the old block size and replications. Okay. So next week, I'll show you with, I will go with the practical part in HDFS, Hadoop distributed file system, LFS. First, I'll go with LFS, local file system. Next, HDFS commands, and also brief you about the software. I'll forward the software to your Google Drive. So I'll demonstrate about it. Yes. So try to get enrolled. If anyone still not enrolled, right? Try to get enrolled. You can see that payment details in the chart, the demo videos, right? And the course content link, the online, what is that? Online team, their mobile numbers, everything, right? Any other queries, anyone, right? Okay, fine. Next Saturday, same time at 5 o'clock. Yes. So once again, okay, yes, fine. Any other query, right? Yes. Okay, I'll stop for now. We'll continue like that. Next Saturday, right? Yes, fine. Ajay Patekar, right? Today there is no demo class. It was not a, right? Ajay Patekar. Today, what was our discussion? Replication and fault tolerance.
Yes, yes.
Yes.
Yeah.
There was no demonstration. Yesterday also I was discussing about this, how exactly the data storage and processing, the replication and fault tolerance, how the task can be assigned, and about the block size changing and modification, the replications, right? Fine. Okay. So I'll stop for now. We'll continue next Saturday. Yes.